Hello. In today's exercise, we'll be examining entity relationships, or ER diagrams. In our context, an entity is a table within a relational database, but ER diagrams can be used to examine many different types of flows or schemas. They are a very useful tool when doing analytics. ER diagrams were first developed by Peter Chen in the 1970s as a way to model and design relational databases. In software engineering, often the first step in laying out a database is to design an ER model. This model will help us visualize the data that we plan on capturing, along with the business rules to help support the model. This data visualization is important in seeing issues before we implement our database or do any programming coding. For example, it will help us see information we need to capture but are missing, or data we are capturing that we are not using. But before we jump to a database model, we need to understand a few basic principles of ER diagrams. An ER diagram can depict relationships between entities, or in our case, tables. For example, let's think of our artists and track tables. An artist can have one song, can have multiple songs, or maybe we don't have any songs at all. The ER diagram depicts the fact that the relationship between artists and tracks is a one-to-many relationship, meaning one artist is capable of having many tracks. This type of depiction of the diagram helps us in designing the tables and the relationships between those tables. There are other relationships that we may want to enforce, for example, a one-to-one relationship. In that case, I may have a customer that only has a single name, or I want to enforce the fact that there is only a single name per customer. But I may have a customer that has multiple invoices. This concept of one-to-one or one-to-many is going to be very important for us as we move forward and we lay out our SQL queries and we design our database tables. Now that we've established the relationship between two entities, let's look and see how we would depict it. Shown are two possible tables, a person table and a location table. And what we want to show here is where each person was born. I know that more than one person can be born in a certain location, so the relationship between the table is many people can be born in one location, but each person can only be born in a single location. So the relationship here is defined as many to one and to only one. If we look at the ER diagram shown, we see the crow's feet on the left with the 0. That depicts that I have many people or 0 people, and on the right I show one and only one location. So this is many people can be born in a single location. Peter Chen demonstrated one way to illustrate an ER diagram, but there are many ways to illustrate these relationships. Other professionals like Bachman, Barker, and my favorite Martin have come up with other methods of also illustrating ER diagrams. Diagrams can be very complicated or they can be very simple. It's dependent upon your need and how you wish to use the ER diagram. Pictured is our Chinook database. Let's focus on the artist and the album tables. We know that one artist can have multiple albums, and the ER diagram that we're showing here depicts that as a key showing the artist's ID and to many albums linked by the artist ID. Let's show how this would look using Martin notation with a relationship of one and only one artist to many albums. Now let's look at a different type of entity relationship. In the employee table, we notice that one employee can report to multiple other employees. So the reports to column is an internal key pointing back to employee ID. Let's create our own ER diagram now, focusing on the artist, album, and track tables. A couple things to keep in mind as we create our first ER diagram. The diagram is an analysis tool. It's there strictly to help us visualize the database and to help us think through the layout of our tables. The diagram itself, the format, may be dependent on what we're trying to convey. You may initially start with a very high-level flow and then start to work your way down into more detailed, laying out tables and specific columns within those tables. I have also found that it typically takes me several iterations before I come up with a design that I'm happy with. So I work on pen and paper first before I actually commit to settling down and finalizing in a more formal way what the ER diagram looks like. So for this exercise, I'm just going to whiteboard our example with our three tables. I'm going to start by just jotting down my table names and the list of columns underneath those tables. The artist table, and the columns are the artist ID and the name, album, the album ID, the artist ID. I draw a box around each table representing the fact that this is its own entity object, and put a line underneath the name of the table so that we know that that's a header. Next, we're going to go ahead and draw the entity relationship. We're going to draw a line from the artist ID in the artist table to the album table. We put crow's feet on the end of the entity relationship connector to let us know that this is a one-to-many relationship. Now let's go ahead and add the track table. Since we know that this will be an iterative process, I'm only going to list the fields that I know that I need to add right now. Later on, we would come back and amend our diagram to list all the columns. But for now, the columns we're going to put in are track ID, name, album ID, genre ID, and milliseconds. And again, we'll surround that entity or object with a box and put a line underneath the header or the name of the table. Now we add the connector or link to the table, and we know that the relationship between album and track is album ID, and the relationship can be a many-to-many. Thank you. This is the end of this presentation.